Welcome to Ship It, a podcast about ops, infrastructure, and databases. Ben Johnson, the creator of Litestream, joined Fly.io a few weeks after we migrated Changelog.com. Episode 50 has all the details. That was pure coincidence. What was not a coincidence is me jumping in the opportunity to talk to Ben about PostgreSQL versus SQLite with Litestream. The prospect of running a cluster of our application instances spread across all regions with SQLite and Litestream replication blows my mind. Let's find out from Ben what will it take to get there. As for Fastly, in the last 28 days, their global CDN served 1.3 million Changelog MP3 responses with minimal latency. Check out what they can do for you at fastly.com.
This episode is brought to you by Sentry. Build better software faster, diagnose, fix, and optimize the performance of your code. More than 1 million developers and 68,000 organizations already use Sentry, and that includes us. Here's the easiest way to try Sentry. Head to sentry.io/demo/sandbox. That is a fully functional version of Sentry that you can poke at. And best of all, our listeners get the team plan for free for 3 months. Head to sentry.io and use the code SHIPIT when you sign up again. Sentry.io and use the code SHIPIT.
We are going to ship in 3, 2, 1.
Ben, I'm so happy to be welcoming you to Ship It. You have no idea. I've been looking forward to this since you joined Fly.io. Welcome.
Oh, thanks for having me. I'm stoked to be on here and chat about, infrastructure and all that fun stuff.
Yeah. So I'll go straight into it. What made you join Fly.io?
Yeah, that's a good question. So I have a project called Litestream where it basically does replication of SQLite databases. It kind of puts them up to S3 so you can kind of run a single node safely. Because most of the small projects I have tend to be real small or even medium size, and they don't get like hundreds of requests per second that are writing in. They're like, in the tens of requests or one, or less requests. Mm-hmm. So I started going down that road, and I just kept finding that, I wanted to find like a place where I could deploy out applications easily, but also had persistent disks, basically like Heroku, but with persistent disks. Mm-hmm. And everyone kept recommending Fly. So they just kept kind of coming up in conversations. And then we kind of, just chatting with them, we kind of realized we were kind of going down kind of the same road, mm-hmm. where like they want to kind of build compute and just make it really easy to run stuff. And they don't want to have to worry about, storage if they don't have to. Like, storage and state are always like the most painful thing to deal with. And if they could just like make it super simple for people to ignore that more or less, that'd be great. And that's kind of my goal too, is I want to make it so that the storage stuff is, as invisible as possible. Obviously state kind of sucks, but you got to deal with it, and minimizing that pain is the idea.
Right. So they were thinking along the same lines as you were thinking when it comes to storage, when it comes to keeping things simple, and you just hit it off.
Yeah. And like, I think that, nobody, like, I don't have anything against Postgres. Like, I think Postgres is great. Mm-hmm. It's super advanced database. It has all kinds of features, but, most of the applications I write, use a tiny fraction of the potential of Postgres. And I find that I really love, like, I used to work in embedded databases a lot. I wrote a library called BoltDB in the Go community. It's pretty popular. And there's a stark difference between like writing with an embedded database where everything is super snappy because all of your data is just like nanoseconds away from you. Whereas when you have to connect into a query to Postgres, if you're even in the same region in AWS, it can be like a full millisecond to do a round trip for a single query. So, there's this kind of different dynamic when you write applications with a embedded database. And I kind of miss the SQL side and a lot of that nice management stuff. Yeah. So SQLite seemed like a good middle ground between like raw key value store embedded database that I had and like a giant Postgres server. So yeah, I kind of landed there, and they kind of had the same feeling. Like, not everyone needs Postgres. Like, a lot of people don't need Postgres, and it can be a lot of overhead management. And if you don't need that, then, SQLite's an awesome alternative.
Yeah. Again, PostgreSQL, okay, we will come back to this because I still don't think we have finished with that Fly.io story. And the reason why we haven't is because soon after Changelog.com migrated to Fly.io, you joined Fly.io, and I didn't know about it. I was like, what? No way. Like Ben joined, like the Litestream Ben joined Fly.io. That's just unbelievable. It's not just Changelog is running on the Fly.io infrastructure, but Ben is also on the team. And you wrote that blog post all in on SQLite Litestream. Mm-hmm. I really enjoyed reading that, and I just couldn't believe it.
Oh, thank you.
We had Mark Erickson in episode 51, and I was thinking, right, I have to talk to Ben for episode 59, and this is it, just before the Kaizen. So the timing, I mean, I just like couldn't make that up. Like some things, they just happen. I think serendipity is how some people call it. And I don't think I'm seeing what I want to see because it's real, right? You joined it. You joined Fly.io, you're there. And you wrote that blog post I had no idea about. And what you wrote in the end really, really resonated with me. So choose any 4. Can you tell us a bit about that? What are the 4 and why can you choose all of them? Because it sounds too good to be true.
I have to think back to what the 4 were now.
Small, fast, reliable, and globally distributed. How can you have all 4? That's just not possible.
Yeah. So, I mean, I think, the first 3 are kind of SQLite's kind of mantra of, keep it fast, small, and, easy. And then the globally distributed part, the way that I think about it is like, the thing that I like about SQLite is that it's almost like a nice building block for a distributed system. Like it has a lot of really cool stuff built into it. It just kind of needs that like, all those fun little distributed systems algorithms that kind of distribute and merge and, control data and the flow of all that stuff. If you can kind of shim that in underneath it and do it as invisibly as possible, then, for a lot of applications, it really works well where you don't have, obviously it depends on restrictions you have for your database. Like if you need a ton of concurrency or write concurrency specifically, then, there can be trade-offs with SQLite, but there's other ways to get around that as well. Mm-hmm. So if you have like, one interesting thing that a lot of people are asking for is they want to really segment their users. So maybe they have a SaaS and maybe they have 1,000 users. Instead of having one big database with 1,000 users and all their data in it that mixes together, they say like, hey, why can I not just build a database per user? They're totally isolated. And for a lot of companies, that's really important that you don't accidentally like miss a where clause and suddenly you're spewing out other users' data. And I think, once you look at something like that, whereas you had maybe write concurrency issues for one big database, if you split it out into 1,000 little ones, you don't really have those same kind of concurrency issues. Yeah. You can write into them in parallel and they don't actually have really anything to do with each other. So I'm wondering, I mean, you're touching on so many interesting points, but the one which just reminded me of a conversation which I had maybe a few days ago. This was with Alex Sims. We had him on episode 49. We talked about this e-commerce platform, actually logistics fulfillment platform. And there's this problem of a main database, let's say a primary, which is the writer, and there's only one, and then you have like lots of readers. But if you have to do any writes from different parts of the world, you have to go through this one primary. And latency is a pain. I want to use a different word, but I'm going to use pain. Yes. So in that in that world, how could SQLite help? In that architecture, how could SQLite help? Because I'm thinking cell-based architectures, and I know that AWS did a lot of work around that. Are you thinking the same thing, or is it something different? It's really more like, the right latency, can be painful if you're coming from across the world. Mm-hmm. But I think there's probably, it depends on your application again. But like a lot of people have an expectation that if they go and they look around at a website, an e-commerce website, and they look at a bunch of different pages, if all those like product pages and the searches and all that are super fast and they're read-only, those can be replicated down to the edge, and you can really like get the absolute best performance there. But I think people have an expectation that when they go to actually check out, that having an extra 100 milliseconds or 200 milliseconds isn't the biggest deal, especially as a trade-off if you have fast read latency. So I don't find that to be like a big issue to put the primary in a single location. That being said, if you wanted to, you could, because SQLite is so lightweight, you could have primaries for some users in one part of the world and primaries for another, in a different part of the world. And it's pretty easy to kind of move those around and segment them. Right. Especially around like GDPR as well. If you have people where you have to have restrictions around that. One. Okay.
we have to slow down with the big topics because each of those, they just like deserve like, I don't know, like at least like 5 minutes worth of discussion, 5-10 minutes worth of discussion, GDPR and Schramm's. Okay. Coming back to the primary and coming back to having a single source of truth. I know that some setups, and especially when you have like a logistics supply chain, you need to know where items are, regardless where they are in the world. And you have to have a single unified view of where things are. Because if you don't, like, how do you reconcile that, right? I mean, it's a single company. It's a single, like organization, single system, and they may have different fulfillment centers around the world, but they still need to have like a unified view. And when you move items across like units, you say, okay, this unit moves from here to here. You need to have a transaction that, doesn't, it just avoids like all sorts of like weird things happening in the system, data getting corrupted, a unit being in 2 places at once, weird things like that. So are there ways that you can have primaries which are closer to you, or basically can you do writes which are lower latency that would avoid having a single primary?
I mean, you could. I mean, you start getting into like eventual consistency stuff, because if you have like a multi-primary, or what used to be called multi-master, then, you really get that issue where you can have 2 records change at the same time. And you have to merge those in some way. And SQLite has some built-in stuff around that. There's a thing called a session extension where you can actually pull out kind of like a changelog or like a diff of your data. You can send that to another database. But honestly, that comes with like a whole host of issues. And like, you're probably a lot better off sharding before doing any of that if it's possible. And, ultimately, like, I think like a lot of problems are shardable, which is really nice. Like if you work in a SaaS, if you work in like all kinds of stuff, those are usually really shardable. But if you have like just a giant database where everyone has to have access to it in real time and like do multiple concurrent writes, SQLite might not be a great fit for that if you really need that concurrent write stuff. It does have really quick writes. So if you can do a lot of really tiny, small writes, those are great. But if you have long running ones, that'll block other writers. So I don't have a solution for you yet. That's great.
I know that is a hard problem for sure. And I know that like Google Spanner keeps coming up and they say, oh, we solved this problem. And again, I haven't looked close enough to know like what are the trade-offs, because there's always trade-offs. Everything is solved as long as you're willing to put up with the trade-offs. And most people, when they start getting into it, they say, whoa, this is too complicated. I'm not doing that. Like, no way.
I haven't looked at how they do a multi-primary, but like, I know you can look into stuff like optimistic locking, where, you might change a row and then hopefully another system doesn't change it at the same time, and then you can back it out later. Or, there's different ways of doing it. But yeah, that just sounds like a pain if you don't have to deal with it.
Yeah, for sure. Okay. So the reason why I was very excited to talk to you is because when we moved to Fly.io, one thing which we did, we changed our PostgreSQL from running it in Kubernetes to it being like almost managed in Fly. No, it's not like fully managed, but it's very easy to set it up. It's easy to set up replicas. It's easy to do all of that. Now, PostgreSQL, I mean, that's, again, the topic for the next Kaizen, episode 60, is how do we go from a single instance of the Changelog app to multiple instances? Because Erlang was made to be run in a distributed fashion, right? It was made for clustering. And it has this concept, it's first class in the Erlang runtime, the concept of a cluster. So with that, if you have multiple instances and they're like spread around the world, then if the database is in a single place, it just makes things a bit more difficult. So I was wondering, is there a way that we could use SQLite with Litestream to have copies of the database, which are basically sitting right next to the apps, or maybe even with the apps? I'm thinking with the apps, right? Of course, with the apps.
Yeah. So yeah, I mean, so the upcoming release of Litestream, we have read replicas coming in there. So essentially you have a single primary and then other replicas connect out to it and stream them down. And that works for a lot of situations where you just need to span out, or scale your reads, or you want to have local reads on replicas. So it'd be a good fit for that. The one downside right now to Litestream, and actually it's ironic that I'm at Fly, is that when you have to restart the primary, it has to, you can't switch a primary right now. It always stays at the same node. So you have write downtime when you switch over. But we're kind of working on it. We kind of learned a lot of lessons from Litestream. We're kind of revamping it a bit and making it so we can do kind of like have the primary move, have a lot of this stuff kind of just invisible to you underneath. So essentially, you should just kind of get a directory that you can write your SQLite databases there, and they just magically appear on all nodes at the same time.
So currently, the setup that you would recommend with SQLite and Litestream is having a primary, which is like where all the writes happen, and then having read replicas. Is that right?
Yeah. Yeah.
Okay.
Yeah. Or if you don't even need the read replication, I mean, just having a single node works for a lot of apps too.
Mm-hmm.
The main downside right now is when you restart, you'll have downtime during the restart. It was originally built more for like a VPS where you have a single server that's always running. And whenever you kind of deploy, you just kind of restart that app real quick, but you can keep running Litestream in the background. So, a lot of people are moving obviously to, Dockerized deployments, and you have a lot more of these kind of restarts. So we're kind of taking everything we've learned from Litestream in the past and kind of revamping to kind of address that new world, Okay,
so just that I understand this correctly, currently, today, if we were to use SQLite with Litestream, and we would push an update that would roll, in this case, the app instance would bring a new one up. Would there be downtime?
Yeah, currently there would be downtime while you roll. Yeah.
Interesting. How difficult would it be to set up a read replica as the application is booting and then promote the read replica to be the writer after it starts?
I wouldn't say it's super easy right now. I mean, it certainly can be done, but kind of the focus of what we're doing right now is really more to there's kind of a lot of lessons learned. We kind of wanted to revamp certain parts to make a lot of this easier. One piece you're talking about, like Elixir, we want to be able to push. One issue that we actually have with Litestream and read replicas is that, sure, you can push data down to the read replicas, but if you have something that needs to notify users when an event changed, like a user updated or some kind of event happened and needs to recheck the database, there's not really a mechanism for that right now. So we're trying to build part of that in as well, so that data changes on the primary, it can basically set kind of a notification to let all the other replicas know that maybe a new user came in, and they can update that. And if they need to stream down data in real time, they can as well.
Right. Okay.
So instead of putting time to try to make the current read replicas kind of switch over and whatnot, we're just kind of revamping it a bit. So that should be available here in the next couple months.
Really? Okay, interesting. So do you know how it's going to work? I mean, do you have like an idea of how we're going to, like, what does the solution to no downtime look like? In your example, you have a primary writer and you have a number of read replicas. Rather than promoting a read replica to a writer, what would you do differently?
That is what it is. The new system is doing. But we're kind of revamping how like Litestream works entirely. So it has currently right now, it kind of just pushes up the write ahead log from SQLite. So it'll basically take a snapshot on a regular basis. So by default, it'll do it every day, like every 24 hours. And then from that snapshot, it'll do every single wall page after that. We compress them down. And right now it ships it up to S3, or, in the near future, it ships it down to read replicas. And then if you ever have, like a node fails, and you need to replay everything, you can just grab the latest snapshot, replay all the wall in between. And then, you can do like point in time restores as well. So the downside, obviously, to all of that is that if you have a lot of writes in between your snapshots, then it can take a little while to download the snapshot and do all the replay. So, some of the lessons learned around that is, figuring out a better format than just the regular wall file that SQLite has. So we can do more stuff around like encryption. We can do stuff around compacting wall files. So we can actually compact them down into kind of a minimum set on an interval. So if you wanted to do point in time restores to some point every, say, 5 minutes or half hour, we can do that, and they're nearly instant. So it's, just trying to take a lot of the little bits and bobs that people, complained about and finding better solutions for those.
Nice. So who are the people driving those improvements? Do you have users that give you suggestions on how to do this? Like what does that look like? That process of, people helping you improve this aspect of Litestream and how it interacts with SQLite.
Yeah, I mean, a lot of people either go through like GitHub and log issues. We have pretty decent sized Slack for Litestream. I think it's a couple hundred people now, and people are very excited to use SQLite. Like, people just love SQLite. I gotta say, if you're ever going to make like an open source project that like builds on something else, find something that like builds on SQLite, because people love it.
Okay.
But it's like, I think there's a lot of people that just have ideas of how they can simplify their stack and just, not worry about all the different like Postgres settings and like setting your HBA for like your user access and all the little different tweaks and whatnot, and worrying about like PG bouncer and all those things. You just kind of like run it and it just works more or less. There's a couple little settings you got to set on there to use it well, but there's, it's just like one or two, like setting the wall and things like that.
Okay. I think I know how you're going to answer this, but still, let's assume that I'll be wrong. Why do people love SQLite?
I think people have a frustration with having so many dependencies out there where just everything always requires like just way too much. This is just way too much like headspace that everything takes up. And you're not actually like building your application. You're like reading docs for Redis or for some caching system or some load balancer or whatever. And like the idea of just like actually writing your app and like the database is there and it just works and it's super solid, but it's not, I think I looked up, I think in that blog post I wrote, Postgres has like, I think their documentation is like 3,000 or 4,000 pages in a PDF. Like it's crazy, which is great. I mean, it's, it does everything, but at the same time, it's a lot to keep in your head. So I think that's the really reason people love it. If they have an application that works for it, then, it feels great to use.
I remember when I got into Rails development ages ago, and by default, Ruby on Rails, the framework, was using SQLite in development mode, and it was glorious. Like, there was like this thing, you install it, you run it, and everything just works. That was like such an aha moment. I was like, yes, everything should be this simple. Well, not when you go into production, obviously, but then you would go like, why not? Like, why couldn't it be this simple? Because there are certain advancements in, for example, disks, storage, the I/O improvements. I mean, let's just like stop like the I/O improvements. I mean, you couldn't do things with regular disks 15 years ago, like the spinning disks that you can do today with SSDs. And if people think that SSDs are fast, well, when you try like an Optane drive and you get like hundreds of thousands of IOPS and you go like, what is this thing? It's like RAM. And it is like RAM, exactly. So the boundaries are blurring between RAM and disks. That's how fast they get. So surely that will change a few things, right?
Yeah, I think that like, when you have over time, you look at like 20 years ago, between 20 years ago and today, like, it's not like things have gotten like twice as fast. It's like multiple orders of magnitude faster. And then, back then it might have made sense. You're like, oh, Postgres can run 10 or 20% faster than, SQLite, say. But, these days when you already have like a 200x improvement in speed of, your disk or your CPU and whatnot, that actual little 10, 20% doesn't really make a big difference anymore. Yeah. Right? Not for everybody. Obviously, some people really need to eke out all the performance they can, but it kind of opens up all these different possibilities for like simplifying your stack while it's still being fast enough. And actually, we're kind of getting this weird place where it's not even the actual hardware that's slow anymore. It's the actual like speed of light where like you physically have to like jump through time and space to pull your data from somewhere else. And if you could just shorten that distance, which is basically what SQLite does, then you can get quite a bit faster. So when I did latency benchmarks between SQLite and in Postgres, for Postgres within even the same region, different availability zones, maybe it could be up to a millisecond just to do a round trip of a single, like a select one. But then if you're doing, locally with SQLite, just the overhead of getting that same query is about, 20 microseconds, 10 to 20 microseconds. So like you don't have to worry about things like N+1 queries so much anymore. If you want to destructure your queries and make them more composable or, just pull out a smaller amount of data or not use an ORM, things like that, it changes the simplicity of your application in a lot of ways you don't really think about upfront. I
think that's what it is. I mean, this feels like it changes everything. Like we thought that it wasn't possible, and all of a sudden it is. I say all of a sudden, like in the last 5 years, it is. But people, many people still think it's not possible. And there are certain things which are hard because, like, without Litestream, how would you run SQLite? I mean, you can run it, but it's very limited, and it actually is designed for it. It works for what it was designed to do. And then Litestream enters, and things just change. That combined with the disks, combined with the networks, the fast networks, combined with like 128 CPUs. Sure, that's normal these days. You can get like, hosts with 128 CPUs. I've seen Kürt post some screenshots from fly.io for like some of the servers, and those machines are crazy. So everything's local. The networks are fast. You have like those VPNs, like WireGuard building everywhere.
Yeah.
That's nice and simple. I mean, that changes everything when it comes to, having a private. So there's like a bunch of things that work really well together. And I was so excited when Litestream just entered this space because it changed. It changed a bunch of things. And I was like, yes.
Yeah, there's been an influx of tools lately that are just, it's nice to like move towards that simplicity that we just feel like we've gotten so complex over the last decade or two.
This episode is brought to you by our friends at Fire Hydrant. Fire Hydrant is the reliability platform for every developer. Incidents, they impact everyone, not just SREs. They give teams the tools to maintain service catalogs, respond to incidents, communicate through status pages, and learn with retrospectives. What would normally be manual, error-prone tasks across the entire spectrum of responding to an incident, they can all be automated in every way with Fire Hydrant. They have incident tooling to manage incidents of any type with any severity with consistency, declare and mitigate incidents all from inside Slack. Service catalogs allow service owners to improve operational maturity and document all your deploys in your service catalog. Incident analytics allow you to extract meaningful insights about your reliability over any facet of your incident or the people who respond to them. And at the heart of it all, incident runbooks. They let you create custom automation rules, convert manual tasks into automated, reliable, repeatable sequences that run when you want. You can create Slack channels, Jira tickets, Zoom bridges instantly after declaring an incident. Now your processes can be consistent and automatic. The next step is to try it free. Small teams up to 10 people can get started for free with all Fire Hydrant features included. No credit card is required. Get started at firehydrant.io. Again, firehydrant.io.
Why did you build Litestream? Do you remember the day when you thought, I know, I'm going to build this thing and you didn't have to? What was that like?
Oh, it wasn't like a single day necessarily. It was like originally I was like, Bolt DB, like running like an embedded database for your application development is just something people don't generally do. Like it's kind of weird. But I was like determined to like make application development work for an embedded database. And, I tried it. I tried like figuring out different schema things I could do with it. I did like putter buffs. You could like encode into like a byte slice and like put that into your database. Then you have to like make your own indexes, and it was such a pain. So don't ever do that. But then, I came around, I was like, SQLite kind of is the nice middle ground. And I was originally trying to figure out how I could like hook into it. There's a bunch of different options you can do. You can do it. They have like a VFS layer, a virtual file system layer inside of SQLite. Mm-hmm. You can kind of inject calls into there and maybe replicate those. You could inject into a layer in the file system, like make a fuse file system, which is like a user space file system. I tried way too many options before I finally like landed on Litestream. And I even like started like porting SQLite code over to Go just to try to understand it better. That's like my way of learning code. And, it just kind of struck me at one point. I think I was reading through some docs that like, the write ahead log, it basically, so Litestream is kind of predicated on this like hack, and it works. It's a good hack, but it's a hack nonetheless. Where SQLite, I have to explain a little bit about write ahead logs real fast. So you have like a main database file, and then whenever you make changes to that file, if you're in a write ahead log mode, it'll actually write those changes. It'll pin them onto another file called the wall write ahead log. Mm-hmm. Each change gets tagged on to the end. And then once it gets too large, it does a process called checkpointing, where checkpointing just basically copies all those pages back into the main database and then restarts the wall. So the kind of the idea around Litestream was that in the docs that says it can't, SQLite can't do a checkpoint if there's any read transactions open, because they might depend on that write ahead log. So what Litestream does is it basically just opens a long-running read transaction against the database and doesn't let go of it. So it blocks all the checkpointing and then manages the checkpointing itself. Like it'll take off that read transaction, force a checkpoint, relock it, and it does a lot of consistency checks to make sure that, the last page that it read off the wall is the same one as it did last time, and it can kind of keep track of its position. So it basically keeps the wall going as long as it needs, and then copies it out to a kind of a shadow background file. Mm-hmm. And then that gets replicated up to S3 So that's the hack right there. I guess the moment, if you want to know, is when I found out I could just hack the checkpointing system and steal all the data. So
wow,
not actually steal, just copy the data.
I know what you mean. Wow.
Yeah.
So it wasn't by accident. It was by trial and error, trying different things, seeing what sticks. And eventually you land across something which felt like, wow, this could work. And this is actually good.
Yeah, basically. And it was 5 or 6 iterations before I landed on what Litestream is. And there's a lot of ways you can do it, honestly. And there's another one called, I cannot pronounce the name. It's like Vercul, or I don't know. It's another SQLite replication thing. And they inject through the virtual file system. So if you're using the non-wall journaling mode, it's called the rollback journal. They hook into that and they do it to the virtual file system. But, that's an extra layer where you have to kind of build your application around that, and you have to, inject it in there in your application. And the thing that I like about Litestream and kind of that external design is you can slap this against any legacy system that uses SQLite, and it just automatically works because your application really doesn't have to know about Litestream. It's like an operational concern, not a development concern.
Okay. So one area which I'm very intrigued about is the idea of an embedded database, because Erlang, and again, Elixir, which is the language, and it's a DSL language that Phoenix uses. Phoenix is the web framework that Changelog.com uses, and Chris McCord is also on the Fly.io team, and he's the one that created it. So again, lots of great people coming together, and there's something there. There's something to, great people coming together. I was just talking to Frederick Bransick, I think last week or something recently, about what happens when great people come together. And that will be, I think, episode 57, I believe. By the time we're listening to this, it's not out yet, but it will be by the time this goes out. Embedded databases in Erlang, there's MnesiaDB. And MnesiaDB, it's often used and abused in different systems because it was built for 30 years ago, systems which existed 30 years ago. The biggest user of MnesiaDB is RabbitMQ, and that leads to some very interesting behavior in RabbitMQ clusters when there's lots and lots of metadata. So RabbitMQ uses it to store users, bindings, policies. It's usually bindings that, really mess things up. But as an embedded database, it works really well because it's just part of the runtime. There's nothing else to do. It's like Go having an embedded database. It's at that level. Mm-hmm. Again, not going too deep into that specific rabbit hole, the concept of an embedded database is really powerful. When you see it used well, and when you see how far you can take it, it makes you think, why do I need this extra dependency? And there comes a point when you absolutely will, but maybe you can take it further. Maybe you can build something on top of that primitive, still keep it embedded, and not need an external system. What would it look like if RabbitMQ needed PostgreSQL to store data? That would be ludicrous, right? You would just what? No. But, it could if it needed to. So embedded database is a concept in the Erlang world. It's normal. It's, it works. Mm-hmm. And that made me think, why doesn't Phoenix have something like an embedded database? Why doesn't Phoenix, run everything locally? You have still data where you need to store that. When you have applications, they're supposed to be stateless. And then when they restart, you don't want, you want to be able to scale them nicely. There are certain properties about that. But Litestream to me sounds like it's enabling a slightly different model for embedded databases. And that's what I find fascinating. The fact that you use SQLite because it's simple, because it's been proven technology, battle tested, it's a great idea. I think SQLite, isn't it the most popular SQL database in the world? Oh yeah. It's on I forget, it's billions or it's a crazy number of devices. It's on every phone, toaster, every phone, exactly. Fridge, it's everywhere. It has it. Yeah, it's crazy. So it's already there. It's already in all those systems. So having Litestream join it, wow, now we're talking. The scale, just the sheer amount of scale, is just mind-boggling. If you think billions of devices, that's just crazy. Mm-hmm. So before we go to billions, how about we start with tens? So if you have 10 instances of the application, what would it look like if the data was replicated without it needing a complicated another database cluster, which, has as you mentioned, thousands and thousands of pages of documentation for good reason. Mm-hmm. What if it didn't have to be that complicated? And that is a very exciting proposition.
Yeah, that's kind of what I'm excited for. Like, and it's funny, like, I think like database engineers are like a unique kind of person where like, if you get into like JavaScript, everything is always like, there's some hot new framework every 6 months. But like, if you get into writing databases, it's like, this thing might be popular in like 5 years. Like, it takes so long to like build it up and whatnot. But that's kind of like what I see happening, or, kind of the trajectory is just, making it as simple as possible and making it more and more invisible. But essentially, yeah, if you have, 10 nodes, a lot of people wonder like, why do I really need to have something replicated across the world? Is it, it's fine just having this one instance here in Virginia. I think people don't appreciate that, 200 milliseconds of latency, if you're going around to like from the US to Asia, can really add up a lot and just makes the user experience pretty rough. And right now, yeah, it can be kind of a pain to replicate everywhere, but the end goal really is just to make it as easy to run, say, 10 nodes as it is to run one, and that you don't have to fuddle around, mess around with like figuring out your primary and like how it replicates and all that stuff. We essentially just want to make it so that, as you scale up, scale down, whatever you want to do, it just kind of works. And even to the point too, where we're working on making it so that it works on like truly like serverless platforms like Vercel, or like things that are like Dino, where it's, pure WebAssembly, that it can actually pull in JavaScript and run that. Or like Cloudflare actually has like a SQLite piece as well. But, there's all kinds of ways where you can kind of like scale out and do different things. And if it can be as easy as it is when you just have a single node, I think that's pretty compelling.
That's interesting. Okay. So when you say, you just mentioned Cloudflare, and they're I was thinking about their key value store. Is that SQLite by any chance?
No. So they have their naming convention. I always get messed up. So they have durable objects, which I think is D0, is what they call it. And then there's, I think D1 is something they built on top of that, which essentially has kind of I think it's SQLite built on top of durable objects. And they wrote a blog post, I think that came out a couple days after the blog post I wrote. And they don't have a lot of details on the exact way it works, but it's essentially SQLite underneath and distributing that. So we'll have to see, as far as performance goes. There's a lot of like nitty gritty details of like how performant something is depending on where you put the data and how it interacts with different parts. But I'm, always excited to see more people getting into the SQLite space.
Yeah. Okay. I'll check it out and also drop it in the show notes because that sounds really interesting. Okay. Are you aware of any applications that do what I'm thinking of doing with Changelog, which is use SQLite, migrating from PostgreSQL to SQLite, replicating all the data, and every single application instance having its own copy, one of them being a primary today, and then having read replicas? Do you know anyone doing this today?
Sorry, you're thinking like taking the data that's in Postgres and converting it in real time to SQLite as primary?
Like not real time, like it's like one-off migration. We go from PostgreSQL to SQLite.
Like do it one time to switch over?
Yeah, and then
sure.
Every application instance has the data. Obviously, we would need for that for the read replicas to be able to promote to masters so that when we have like a fleet of 10, we do like a rolling update. The master just keeps moving around. And eventually, all instances get updated. I'm not sure how that would work in practice. There's like a lot of things which we need to improve when it comes to boot times. And we do certain things, which it means every app instance boots for, I think, 90 seconds today. And if you have, 5 of those, that's, a really long update. But do you know anyone doing something similar using SQLite instead of PostgreSQL?
I wouldn't say anybody doing like moving around the primary. I don't know anybody doing that right now. The replication stuff is still kind of in beta, or like it's, it's pretty early stage right now. There is someone running in production. I just found out the other day.
Wow. Okay.
But, they're brave soul. But no, I wouldn't say right now. And I think making all that stuff really easy is going to be probably a couple months away. Making it so it can move the primary. But that is the end goal.
Interesting. So, okay, that makes sense. And that gave me a different idea. Because I really want to run this in production. I want to be that other brave soul that tries it, and maybe not with Changelog straight away, even though it's like very interesting to see how it would work at this scale, but maybe at a smaller scale. And I'm thinking WordPress. There's a lot of WordPress websites out there. They don't need MySQL. They have very little traffic, many of those. If they had the SQL, and there's always a single instance, if it goes down, they're usually on long-running hosts anyways. They don't tend to be running on Heroku or Kubernetes, and even if they are, they have a persistent disk. And if they don't, there's like object storage, but things get complicated. So maybe for those types of applications, SQLite with Litestream would make sense. Do you know anyone doing this today?
Yeah, there's a lot of people doing that kind of stuff where they run a single instance. I mean, WordPress is a great example. There's another guy named Michael Lynch who he has some applications. He just like keeps like porting stuff over from like Firestore or whatever and rewrites them and puts them in like SQLite and uses Litestream and blogs about them. But he's done stuff where he's taken an application that ran on Heroku and he could like run it with Litestream and it would, replicate in real time, and then he'd like destroy it and then rerun it on fly.io. And since everything's on S3, it just magically works and comes back up. Mm-hmm. And he actually doesn't even run with a persistent disk behind, although I recommend that. But he'll just it just kills it and then just replays all the data when it comes back up. And yeah, he did a blog post. I guess he pays like 3 cents a month for his data storage.
Wow, that's crazy.
The funny thing about S3 is like, this is another real hack around like Litestream where, Amazon, they really make money when you like download data from S3. That you put up your data and then you kind of put it on CloudFront and like a bunch of people download it. And it's pretty expensive and they make gobs of cash. But if you just are only uploading, which is basically what backups do, the actual cost, like I think Ingress is free, the actual per data or gigabyte. And then I think you pay per request and it's like 10 thousandths of a cent or something like that every request. So if you're not doing constant writes, if you're only getting maybe, a write every 10 seconds or something like that every minute, then, your cost can be super low and you're just paying pennies per month for that kind of replication.
That's exactly what we used to do. Every hour, we used to back up the entire database. And it was so cheap to do that, the entire Changelog database, that it didn't even make sense to have like deltas, diffs, write ahead log like backups, none of that. Everything like do a dump, put it there. Do a PG dump. Let Postgres. Okay, let me just reword that so it sounds correct. Do a database PostgreSQL dump. I don't think I can. Like the word dump is just like it's just very tricky to work into a conversation. But okay, this is about database. Okay, so let's get serious. We would do a PG dump every hour, send it to S3, and not worry about it because the cost was so little. When you would have to restore, we would download, it would be compressed. So it'd go from 1 gig to maybe 100 and something megabytes. So a 10x compression, it would compress really, really well. And we would, do that. And when we would have to restore once every in a blue moon, or when we would test restores more often than we actually would have to restore, it was, again, very simple system. It worked. And we used that for a long time because when we set up clustering, we had issues. So with Fly.io, we don't have that because it's all managed. So, we don't have to worry about that. It's all just, built in. But when we had to use operators in Kubernetes to do that replication and configure things would just go wrong. Like the write ahead log would just get blocked and then, replication would stop working and then the write ahead log would fill up the disk and we had like, all sorts of like weird cases. And, that's just not a world I want to go back to.
Yeah. Running state on Kubernetes is painful. I did that for years and it's not easy.
Did you run PostgreSQL on Kubernetes?
Not Postgres. I worked at Influx Data. We wrote InfluxDB and we ran a lot of the cloud stuff on Kubernetes. So it was all stateful and there was a lot of YAML in my day.
Yeah. Oh, yes. Tell me about it.
Okay. Man,
yeah. So things are very different now, but not having to deal with that complexity, it's so nice. And when you start with a simple system, which SQLite definitely is, it just allows you to do things differently. And it just gives you more headspace. It just gives some of that headspace back. And I'm really appreciative to that. Simple things.
Yeah. And actually, like, even backing up every hour I think it's a great solution. We actually, on the Litestream website, we have a kind of a page of alternatives and how you can do that. But even like a script for like, hey, you can still do a cron based backup every hour. You'd name your files based on like a repeating kind of date format, and it'll just overwrite the last one and you'll have kind of a rolling backup. And, honestly, it works great. Like if you don't need the immediate point in time stuff with Litestream, or you want to run Litestream and a cron-based backup at the same time, like they're not mutually exclusive. So I'm overly paranoid about data. So I tend to like back everything up, twice.
So, that's a good idea.
Like I'll do a cron-based backup and Litestream and run them at the same time. It's so cheap as well. And like, the backup script, the cron script is like a couple lines of code, so it's not hard.
Okay. And do you back up to different location than S3, or is it a different bucket? What does
I probably should, but no.
That's great.
It's going up to S3 as well.
Yeah, that's one thing to improve for sure. Because that's when I was thinking, okay, S3 it's great. I'm sure it's going to be fine. But what if we can do just this one other place? And I know that R3 from Cloudflare, we were thinking about that. And especially when it comes to like the trialing it out, let's just, do like set up another backup location, see how well it works. And if we like it, maybe make that our primary backup location or, whatever.
Yeah. And Backblaze has super cheap object storage. They're pretty good. GCP and Azure and all that.
All the big ones.
Yeah, all the big ones, yeah.
I know what you mean, yeah. But Backblaze, that's a good shout out because I use Backblaze to back things up myself, even though I have ZFS and it never failed me, that file system. It's amazing. I still back everything up because, what if it fails one day? Or what if an upgrade goes wrong? And they sometimes do. Rarely, but they sometimes do. You don't want to find out.
Someone was asking on Litestream recently if it could do Google Drive and Dropbox as a destination, which you can technically. Like you can do like another file location. If you have it as a mount, you could just copy over to that. So, that's a kind of a simple hacky way to have an alternate location too.
This episode is brought to you by our friends at SourceGraph. They recently launched a new feature called Code Insights. Now you can track what really matters to you and your team in your code base, transform your code into a queryable database to create customizable visual dashboards in seconds. Here's how engineering teams are using Code Insights. They can track migrations, adoption, and deprecation across the code base. They can detect and track versions of languages or packages. They can ensure the removal of security vulnerabilities like Log4j. They can understand code by team, track code smells and health, and visualize configurations and services. Here's what the engineering manager at Prezi has to say about this new feature. Quote, "As we've grown, so has a need to better track and communicate our progress and our goals across the engineering team and the broader company. With Code Insights, our data and migration tracking is accurate across our entire code base, and our engineers and our managers can shift out of manual spreadsheets and spend more time working on code." End quote. The next step is to see how other teams are using this awesome feature. Head to about.sourcegraph.com/code-insights. This link will be in the show notes. Again, about.sourcegraph.com/code-insights. And by Acuity, a new platform that brings fully managed Argo CD and enterprise services to the cloud or on-premise. The platform is a versatile Kubernetes operator for handling cluster deployments the GitOps way. And I'm here with Kelsey Hightower, angel investor and advisor to Acuity. Kelsey, why are you excited about Argo CD and what's happening here with Acuity?
When I think about Argo CD, it represents the transition from traditional CI/CD. You have a big server with a built-in workflow engine, and you can only do what that system can do, whether it's Jenkins, whether it's Spinnaker, you name it. Those things tend to be all-in solutions, and they're all predicated on having like their own built-in workflows, UIs, and ways of doing things. And then when I think about kind of the Argo CD, that whole open source movement kind of backed by the ideas we saw in the Kubernetes world, which was each of those steps is nothing more than just a step in a workflow. And after 10, 20 years of doing CI/CD, how best to represent those steps? And it turns out this whole container thing is probably the best way to have little snippets of logic sit at each of those steps in the workflow, and then you can kind of exchange them and share them to build any pipeline you want. So the way to look at this is Kubernetes has never had a workflow engine or tool. And so when you think about kind of Argo workflow or Argo CD, which is kind of a specialized workflow, kind of attacking the how do you roll out software problem, that's the way I would think about it. So if you're all in on Kube and you like the Kubernetes ecosystem, then you kind of have a choice of workload types. And I would probably just say it's another workload type you can put in your toolbox. So if you got something that can benefit from a workflow engine and reuse the logic that you already have in containers, it kind of feels like the perfect fit.
The perfect fit. All right. Thanks, Kelsey. Well, the next step is to head to acuity.io/changelog. They are inviting all of our listeners to join the closed beta. Again, acuity.io/changelog. Links are in the show notes.
So we talked quite a lot about applications and the web because that's my primary focus. But I know, and we've touched up on this, a lot of people use SQLite with mobile phones in the context of applications running on mobile phones. I mean, do you know anyone using Litestream with a mobile application that uses SQLite?
I don't know anybody doing it on mobile right now. People have been interested in it, how to sync data down. The biggest thing with mobile is that you really only have a single primary for your database.
Yeah.
And if you made it your phone, you could do it, I guess. But typically people have like a server and they need to sync data between and merge conflicts and stuff like that. So something like the session extension is usually a better choice if you want to do something around that.
Right.
But it's an interesting idea. I mean, having an offline database locally and all that.
Okay. Now, you mentioned something very important, GDPR. I know that many people think about that. Many people think about data locality, the laws and rules that govern where data is stored, where data is transferred to. I think that in that world, SRAMS 2 as well, that's coming, which are even more stricter rules around data and where it should reside for European users. I see a future where data locality is going to be very important, and the data will not be able to leave certain countries, not even like in transit, encrypted, doesn't matter. No. It will always stay in that country. In that world, I think cell-based architectures, the sharding, but even like cell-based architectures, local-based architectures will become very important. Mm-hmm. Do you see Litestream playing a role in that world?
I mean, Litestream, but also just like SQLite in general. I think the simpler you can make your primitive of where you store your data, the easier it is to control where your data is. If you have to spin up a bunch of, if every, region needs its own primary and replicas and all that, and you're running on Postgres, that can be kind of painful if you have, 12 different clusters of Postgres. But if you're just throwing a SQLite database on your application node, that's a lot simpler to manage and kind of make sure that, data doesn't need to transfer between your database server and your application node when your data is already on your application node. So, I think it makes sense. I think you could do it either way, but I like to think that SQLite's a bit simpler.
In that world, one thing which I cannot imagine is how would a team that works on this application manage, first of all, in their heads, the idea that there's N versions of that application, each with N data stores. I mean, each basically has their own. So you are looking, you would need basically to have some sort of a regional routing so you can get to specific nodes. And then that node only has data for that region. I think that can be mentally really challenging. How do you think about that, if at all? Have you thought about that?
Yeah, I think if you really need the isolation, maybe you're setting up a separate VPC for every one that you need to isolate for. And you can control, if you're using Amazon, for example. But yeah, I agree. I think the other interesting piece, with the SQLite, it seems like a small thing to switch out SQLite and Postgres, or conceptually at least. But when you have something like Postgres, a lot of times people put other things like caching in front of it, maybe like a Redis or a Memcache. And you end up having a lot of external systems because you have this kind of slow data transfer, or the latency between the application server and the production server. So, if you remove that latency and you move the data stored directly onto the application node, you really don't need a caching layer. A lot of your data is probably going to be in memory anyway, just through the OS page cache. So, those lookups are super fast, and you're spreading out your reads anyway through multiple nodes. So, I think you're getting rid of not just Postgres, but a host of other systems that are kind of built around it. So I think the next, evolution of the SQLite world that I'd love to see is systems that are traditionally other services, other servers that are kind of built into SQLite. And a job system would be awesome. I keep wanting to build a job system for SQLite where it just kind of works, and it'll call your code and it'll just automatically do that thing. Mm-hmm. I think there's a lot of architectures you could make for that. It could be a library built into your application, but then you're kind of dependent on the programming language you're using. Mm-hmm. It could be even an external system that then calls into a binary and runs jobs. So because SQLite is a multi-process system or a multi-process database, so you could connect to it from multiple processes. So I don't know, I think it's a really interesting space because you can really have kind of a single binary where everything kind of lives, if you're building Go or Rust or whatnot, a couple other languages too. But yeah, just that you can ship a single file and that is what you're running. It's just it's awesome.
Super powerful, definitely. So when you mentioned about a job system in SQLite. I don't have the mental model that you do. Can you expand a little bit? What would that enable if SQLite had a job system?
I mean, the biggest thing with a job system, like, a lot of people I come from the Go world mainly. And, people kind of think, oh, I'll just shoot off a Go routine, which is kind of like a thread or a coroutine. And I'll do whatever this work external to, maybe the request that requested it. But the downside of that, obviously, is if your system dies, then you lose all that stuff because it's all in memory. So the biggest piece for the job system is really just maintaining that state of like, hey, I want this job to run, and then something will pick it up at some point in the future. Maybe you could schedule it in the future, maybe it runs now, and then if it fails, you can retry it. You can kind of keep a log of that status of what that job is. So, I think it's something like, was it Sidekick or Rescue? Mike Purim developed those. Something like that, but like an embedded database layer. And I think that would kind of resolve a lot of issues people have with developing against just a SQLite database. Usually jobs comes up. So I think that'd help a lot.
Okay. How would that help? How would the job system in SQLite help Litestream?
I don't know that it would help Litestream other than just add adoption for SQLite. Because, jobs they're pretty critical to a lot of different systems. If you need something that runs nightly, if you need something that runs every hour to do some kind of bulk processing, you really kind of need that job. It kind of sucks to rebuild that in your language by just like making a timer and hope that it's good enough. So that's kind of where I see it.
Okay. So you mentioned this piece of work that you're currently focusing on in the context of Litestream, getting your read replicas, being able to promote them to primary writers. Are there other things that you're working on in the Litestream space, or things that you would like to be able to work on?
I mean, that's mostly what I'm working on right now, as far as we kind of want to make a layer where it's a bit agnostic to the underlying replication. So we can have different models. Some people really want to have like a synchronous replication model. So you really don't lose any data, but you do that at the cost of, maybe slower writes, because you have to confirm your write to a secondary every time you do a write. An async model where maybe you have a bound of an upper time that you can lag behind on your replicas. A lot of things like that. I don't know if we go as far as like a raft model where you actually have distributed consensus. There's other tools like SQLite that are good for that. So, I think there's some interesting stuff in that space. And, that's kind of my current focus. I would say there's one tool that I made. This is another hack. I feel like my whole career is just a bunch of hacks.
Isn't it for all of us?
Yeah, exactly.
That's how you know you have a successful career. You've done lots of crazy things, a few stuck, and they're brilliant hacks.
Oh man,
just to be clear.
I have so many hacks that just never took off. But another project I work on it's called Postgres, and I think it has a ton of potential. I just don't have any time for it right now. Where one big issue that people have with running SQLite in production is that, like, if you use a command line tool, like I typically use like a command line SQL tool, or even with Postgres, I use the PSQL. And you just, SSH in, run your commands. That's kind of how I work. But I know a lot of people like having a GUI around that stuff. And the big problem, obviously, with SQLite is that you can't SSH over to it and run a GUI with it.
Yeah.
So Postgres actually, it runs a proxy around your SQLite database, and it listens via a Postgres protocol. So you can actually connect your Postgres tools, your GUI tools, to your SQLite database on a remote host through that. And I'll dig into the implementation because I think it's really cool. So the hack around this that makes it work. So the biggest issue, people kind of tried to do this a little bit in the past, but the biggest issue is that when a GUI tool connects, it tries to get like all the PG catalog information. So like all the table names and the columns and whatnot. And that obviously doesn't exist in SQLite. So what Postgres does is so you can do a thing where you attach databases onto other databases in SQLite. So you can kind of query between the two. So what it does is it actually attaches an in-memory database to your database and then creates and it's called PG catalog. And then it attached virtual tables onto that. So they're just like fake tables that, Postgres generates for you. So it can list out the databases and columns or whatnot. And yeah, so it essentially just like hacks together this PG catalog for your SQLite database and then communicates over the PG wire protocol. So yeah, it's a fun little tool. And I think it has a ton of potential. And it actually works, but I mean, it's just not well tested.
Is this somewhere like on a GitHub or like a repo that people can go and check it out?
Yeah. If you go to github.com/BenBJohnson/Postgres, so POSTLITE.
Okay. we'll see if anyone of the listeners is interested, have a look. I'll put it in the show notes.
Yeah, if anybody wants to contribute or maintain it or, hit me up.
That's a good one. Okay. So is there anything that you would like to know about the changelog setup, infrastructure, how I'm thinking about things, where I would like to take things, why, anything that, would be interesting for Litestream maybe?
Yeah. I think that you guys have an interesting setup. You're still in Kubernetes, right? Are you running Kubernetes in Fly or not anymore? Okay. You're totally off of it.
We migrated from Kubernetes to fly.io. Yeah.
Yeah. That was a lot of YAML you just tossed in the bin.
Oh, yes.
I think I'd be curious then. Okay. I had in my head that you're running Kubernetes on Fly, which would be impressive, which I think does work actually, but that seems like overkill. I guess, what is your goal? I know a lot of the stuff you guys build, you have like an intellectual curiosity. You want to be engaged and know the actual system, but are you looking to in addition to that, are you looking to reduce latency, reduce configuration overhead, just make it easier, make it simpler? I guess what would be your pain points that you guys have right now?
So I think right now, I don't think it's so much as of a pain point. It's more like an improvement that we could do. So I mentioned the slow boot times of applications, and there's only one instance right now. So we would want to go from one instance to multiple application instances. But if every application instance, when there's an update, takes 90 seconds to boot, that's a bit too long. They do a bunch of things that they don't need to. So we will be looking at improving the boot times. Mm-hmm. But then you have multiple applications and we still have the CDN in front. And that's great, right? Because we just need to be in so many locations. The application is very read heavy. Mm-hmm. But our integration with the CDN hasn't always been great. And I think we talked about it in episode 50. Even during our Fly migration, there was a misconfiguration of our CDN, which was as a result of using the UI incorrectly, the CDN UI. So there was that episode. But just simplifying the way we do things and basically sharing it with the world, right? This is what we did. This is why we did it. We start with the why, and this is how we did it. So there's a pull request, there's the story, there's even an episode like this one where we talk, to the ones that, helped us, gave us the idea. So I'm wondering, what could we do better than we do? Literally, how do we improve what we have today? How do we make it simpler? Yeah. How do we make it, in this case, boot faster? How can we have more than one application? Because before every single request ran through the CDN, the website would be down when the application instance would be down. And we could only run one because we had block storage and there was write once.
Sure.
So it wasn't write many. And that meant that we could only have one instance running. But now on Fly, now we have PostgreSQL. Now we have actually the object storage. That's the most important one. All the media is stored on the object storage. In S3, it's no longer stored on a volume which is attached. And that's a huge, actually that's the first step towards having a number of application instances. But then there's a database, and in Fly, if we spin multiples, they will run in different, zones, in different, do they call them regions in Fly? I forget the exact name.
Yeah, regions. Yep.
So they will run in multiple regions, and then the database primary will be in one. So I'm thinking, is there something we could do about the data so that, it's local, it's faster? And that's why, I was curious to talk to you about to see where SQLite and Litestream is. And I think it's getting there. There's this first hurdle for the application to not have to go down when there's an update. But I'm feeling good about that. I have to say, I like how you think about it. I like how methodically you go over that improvement. And I know it's going to take a while, especially if there's something that you can trust. And that's why I'm curious to see, where do you see Litestream going, so that I know, does it match what I'm thinking? Yeah,
ideally, honestly, our goal, at least inside of Fly, all this stuff is going to be open source. But the benefit of me being at Fly is we can tightly integrate it as well into everything we're doing. We essentially just want to give you a directory on the instance that you have, and you just write to it like a regular SQLite database. You don't have to know anything about it, and it just kind of magically works. And then it's instantly, or given the speed of light, instantly on all your other instances at the same time. So it's not that you have to think, oh, I need to configure this, and I need to set the number of replicas, and I need to configure the primary, and I need to do all these different things, and I need to set backups and whatnot. essentially you just set a flag on your deploy and say, hey, I want this directory, this magic directory, and it just handles it all for you.
That's really cool.
That's, I guess, from the grand, idea of what we're doing, that's the goal. And, we want to make it work on everything, really. Like, even if you're running Kubernetes and you want to run SQLite on Kubernetes, it should work there as well. So, hopefully we just simplify the stack as we go. And as far as like what you guys are doing, I think that like the CDN is a big thing, like moving stuff up to object storage, especially large files, is great. I know there's some CDN stuff that we do, like if you can serve it straight out of the instances, or we pull off static files and we can serve those separately. That might simplify your stack on fly. I would say, do you know the startup time stuff? Is that part of, are you guys deploying as an app? Or I don't know if you looked at the new machines stuff that Fly has.
I've seen the new machines. We're not using those. We're still deploying as containers. So we build a container image and then it pulls down the container image. Actually, we publish it with like Fly. And I think there's some improvements to be done there, but the boot times, it's actually the application trying to still synchronize things. And that's something which I'm going to look into over the coming weeks. So the application, it's still thinking that it needs to back things up to S3. That's the initial logic which we had, because on boot time it would say, do I have to back things up? And it would do that in terms of synchronizing files. But it no longer needs to do that because everything is on S3 right now in terms of the static files.
Yeah, that makes sense. Yeah, if you look at the machines as well, I mean, once you get application side startup latency going or worked out, the machine stuff really is snappy. Like you're essentially like the app, so the Fly apps kind of manage your scaling and like are kind of a higher level layer. And the machines are really like, I want to boot up an instance, like a specific instance in this region, and I'll put my application on there, and I want to boot up a specific instance somewhere else as well. You get a lot more fine-grained control, but they're also a lot faster. So you get, sub-second startup times from those. So those are pretty nice. Yeah, and we just released those, I think, in the last week or so.
Yeah, it's very recent. Okay. I will check those out because I've seen them being mentioned, but I didn't have time to dig into them. But that sounds really, really interesting. Okay.
Yeah, I think it's a cool thing. Like if you don't need that higher level like management of deploying the app and scaling, like auto scaling and all kinds of stuff like that, it can be like a great option just to get super snappy machines.
Yeah, I think so. So one more crazy idea, and then we go for the wrap up. What would it look like if we didn't use a CDN and we would have many application instances all running on Fly across all the regions which we have most users in? They will be close to our users. The application itself would be basically like a CDN edge location. It would cache everything that it serves in terms from the object storage maybe. And the data would be also local from the database, like lots of reads, but everything will be local. So we don't have to have primary and going, from the edge location to the primary. So all the reads are local. Do you imagine that working?
Oh yeah. I think that's sort of the goal is with Fly as well. It's like, we kind of want to get rid of the CDN more or less. Like, you don't really need a CDN if you have your application nodes running at the edge. They can serve those static files themselves. Or, even today, you can run Postgres and have replicas around the world as well. So yeah, I think that would totally work. It's great, if you guys have a very international audience as well. So like, having servers down in South America or Asia, Europe, Australia, like I think that'd be Africa would be great. So.
Yeah, I was just looking, I think when I do the intros for the episode, I check a couple of interesting facts out and I just mentioned them in the intros. And 2 episodes ago, I was looking at all the CDN edge locations that serve traffic. It was 93 in the last 7 days. So 93 edge locations served.
Oh, wow.
Yeah, some amount of traffic. It's a lot of locations. But there's always like the first 10 or 20, which are the busiest. And then you have like a very nice small tail. It's a short tail, which means that there's not many, from the last 50 or so regions. And I think there's a couple of important edge locations, and then the rest, it's good enough. It's close enough. It's still milliseconds. It's not seconds. So
yeah.
But the one thing which I'm still in my head is not clear, if the application is basically acting as a cache essentially for the object storage, when the application gets restarted, the instance, then all the caching which it had, it will disappear.
Yeah, if you don't have, are you doing persistent disks on those instances, or are they ephemeral?
So they're all ephemeral. We don't use any persistent disk. But that's interesting Because if we did...
Yeah, you could do it persistent. I mean, you could always just pull down the cache again. But yeah.
Oh.
Because there is going to be a limit on how much you can store on the ephemeral drives. I think I don't know that we publicize it. You can test it out, I'm sure. But I don't think it's a stable number.
No. I think pretty sure we would want persistent disk for that. But the persistent disks are only there to basically persist the cache, so that when we restart the instance, we reattach the disk and we still have that previous cache. We don't start with an empty cache, with a cold cache, because that would not be good even for like the object storage bill.
Yeah, I mean, I would definitely look at like machines and then attach volumes on there. And then, I think that's a great way to make it super snappy. They restart fast, and that would probably be the way to go.
Now I'm probably dreaming. Well, I was like kind of dreaming at the beginning. Now I'm like way ahead in the future. All right. Okay. Coming back into the present, as we prepare to wrap up, I'm thinking, which is your key takeaway, Ben, for our listeners, the ones that stuck with us all the way to the end?
Sure, yeah. I think key takeaway is that, if you're looking to simplify your stack, I think that, in any technology, and Litestream included, it's always an evolution. So I think if you're interested in simplifying your stack, doing, working with an embedded database, just having that really snappy, fast back and forth between your application and your database, I would love to have people try it out, give it a try. Maybe it doesn't fit for maybe your big, huge application that, some Fortune 500 companies running on, but there's, thousands, millions of applications that don't have those same requirements that can do something simpler. And, we're continually improving and revamping and, making it better over time. And the feedback from the community really kind of drives a lot of that. Mm-hmm. So I say, jump in, reach out to me. I would love to hear people's feedback on their experience and, what they're looking for sure.
There's more feedback coming your way, Ben. I'm very excited to try Litestream in a couple of situations, but I'm especially thinking about WordPress. I don't think many people know this, but they will find out in the next few seconds. I still host maybe 20-something WordPress websites, and I've been doing so for over a decade now. And I'm thinking of improving that infrastructure, and I'm thinking of giving SQLite and Litestream a go with WordPress to see what it looks like.
Yeah, I'd love to hear your feedback on it. I think it's a great fit.
Well, thank you very much, Ben, for today. I had a lot of fun talking to you. You just gave me so many ideas, and I'm looking forward to what you do at Fly. I think it's a great combination. Kürt is just building an amazing team. I mean, I cannot imagine a better place for Changelog to be running on, and I'm very much looking forward to what we do in the second half of this year. And 2023, oh boy, even my dreams aren't big enough for what is to come, I'm sure of it.
Yeah, keep getting bigger. No, thanks for having me on. It's been great talking to you.
Thank you, Ben. Until next time.
Oh yeah, have a good one.
Thank you for tuning into another episode of Ship It. Check out our other podcasts for developers at changelog.com/master. You can connect with like-minded developers via changelog.com/community. Thank you, Fastly, for the worldwide low-latency changelog.com. Our listeners love those blazing fast MP3s. Your beats are awesome, Breakmaster Cylinder. That's it for this week. See you all next week. One last thought. Make time for team offsites, especially if your team is remote. We just had ours and it was beyond amazing. You are a crazy good bunch, Camille, Guillaume, Helder, Jean-Francois, Sam, Tongi, and Tom. I wish the same good time for you and your team.